Hello, welcome. Today we're going to be looking at distances along the parallels of latitude under longitudes and latitude. Now, how do we solve problems relating to distances along the parallels of latitude? Now, let's take an example so that we can study this. Now, find the distance measured along the parallel of latitude between 2 points whose latitudes are both 56 degrees north with longitudes 23 degree east and 17 degree west respectively. Now, I told us that whenever we have problems of calculating distances in longitudes and latitude, now given that both points, this point and this point, have the same latitude. Now we check the longitudes. We check whether the position or the direction are the same. If the directions are the same, like this is west, this is east, so they are not the same, that means you have to add. But if it is west-west, you have to subtract. If it is east-east, you have to subtract. But because this is east and this is west, you have to do what? Add. And that's why we added the two angles to get this. Now, when we are calculating along great circles, that is along the equator and the meridians, we said that once you get the difference in the angles, whether you are doing addition for the one that has different directions, or you're doing subtraction for the ones that have the same direction. Now, since you are having the one with different directions, you have to add. So once you get that difference in angle, whether you get it by addition or subtraction, just do what the angle is, all over 360 times 2 pi r for great circles. But if you're talking about latitude, parallels of latitudes, instead of having 2 pi r, where r is the big R of 6,400, you're going to be having this small r, and this small r is the same thing as saying 2 pi the big R cos the angle of the latitude. So that is the major thing that you need to understand about this calculation. It's still the same thing. Get the difference in angle, all over 360 times 2 pi r. But instead of having the big R as in the calculation for great circles, you are now having small r, and the value of this small r is simply 2 pi the big R cos the angle of the latitude. So once you fix that, you're going to get this. So that is the main point, and that is the main thing that you're going to be looking out for, because in the exam condition you may not have time to be making all these diagrams. These diagrams actually makes this solution very simple. But if you're in the exam condition, you might not be drawing to explain all this. This is what you go through. Check out the angles, provided they are having constant latitude. Check out the longitudes. If they are having the same direction, if it is east-east or west-west, subtract. But if it is east and west or west and east, add them up. Then the angle that you get, all over 360 times 2 pi r, if it is for great circle. But if it is for parallels of latitude, 2 pi small r, where the small r is equal to big R cos 56, cos the angle of the latitude. And that's how you go about it. But if you want to look at this critically, this is where it is represented. These are the 2 points. We have this point and we have this other point. This is the R. So if you consider this angle CAO, you're going to find out that this small r is equal to this big R cos 56, which is this angle. And that is how we come about this. Now CAB is simply the addition of these two angles, giving you 40. So that arc CB will be equal to 40, which is total of this all over 360 times 2 pi r. That is the formula for an arc. But this small r is actually equal to r cos 56. So in place of small r, you put r cos 56 to the same formula of the arc so that you can solve that. You know that 2 pi r is the same thing as saying 2 times 22/7 times 6,400 to give us this 40,000. So when you multiply out, you'll be able to get this as your answer. And that is how you go about solving this. So very simply, the calculation for parallels of latitude and great circles, they are very similar. Only that for great circle, you're using this r in this formula. You're using the big R. But for latitudes, you're using small r. But noting that this small r is equal to big R cos the angle of the latitude. So that is where we're going to be stopping today. Please, if you like this video, hit the subscribe button by this side of the screen. If you have any questions and concerns, drop it on the comment section. If you want to contact us, check the description part of this video. Thank you and God bless you.